Okay, 37, determine whether the following pairs of function are inverses. I'm just going to do part A here, and you can use the same process and check the answer key for part B. So the idea here is if two functions are inverses, I should be able to you take an input A, put it into f of x, then we take the output of f of x and put it into g of x, and then if A comes back, then we know it undid. And then the other thing is we have to check it both directions. You can't just assume it works if it works one way. So the other thing is then we have to take some generic number, we'll use A again, I guess, put it into g of x, take g of x and put it into f of x, and then if A comes back, then it undid. And if these both happens from both directions, then we're prepared to declare them inverses. So let's try that for this problem here. If I take the letter A and put it into f of x, that gives us f of A, which would be 3a minus 1. So now that's our output. I have to put that output into g of x. So we'll have g of 3a minus 1. And then we'll go ahead and substitute that in. 3a minus 1 goes in for x. So x plus 1 over 3. And now we have to simplify this. So this is 3a minus 1 plus 1 all over 3. Negative 1 plus 1 cancels. This is 3a over 3, which is just a. So we put in a, ran it through both functions, a came back, so that's good. And now we'll just check the other direction. If I take a and put it into g of x, we get g of a, and that equals a plus 1 all over 3. Now we have to take that output and put it into f of x. So we get f of a plus 1 over 3. And so every place we see an x, we've got to put a plus 1 over 3 for f. So 3 times a plus 1 over 3 minus 1. And now we simplify. 3, we have multiplied by 3 here, divide by 3 here. Those can cancel. And we get a plus 1 minus 1 plus 1 minus 1, 0 equals a. So this, again, we put a in, a came out, it undid. So this problem, G and F, are in fact inverses. For part B, you can use the same process, check the answer key, but you should find out that these are not inverses when you go ahead and do the work. You'll actually find that you can actually declare them not inverses as soon as one of them doesn't work, because in order for it to be inverses, both have to work. So once you just did one side and it didn't work, you could just decide that they were not inverses. But sometimes it's nice just to do both directions to make sure that you just didn't make a mistake in the first direction. Okay, last problem here. This is just trying to put some inverse question in context. So this is saying our cell phone bill is a fixed $40. And so that's your per line charge, plus you pay $3 per gigabyte of data used. I probably didn't need to give you the function here, but just in case, this is what this function represents. If x is the number of gigabytes, the cost of your bill is 3x plus 40. So for example, if you used 10 gigabytes of data, your cell phone bill would be $3 times the 10 plus 40, or $70. So the question here asks you to find the inverse of this function, and we can just use our standard process. We're going to replace y here, 3x plus 40, switch x and y, so you get x equals 3y plus 40. We're going to solve for y, so it's minus 40 on both sides here. That gives us 3y equals x minus 40. And then we have to divide both sides by 3. So y equals x minus 40 all over 3. And then we'll replace that with the right label. C inverse equals x minus 40 over 3. So that's the inverse, but it also asks you to explain what it means in context. Well, this function undoes. So the regular function, you put in gigabytes, and out comes the cell phone bill cost. Here, what we're undoing is we're going to put, since we're going to undo this, so our input is going to be the amount of our cell phone bill, and the output is going to be how many gigabytes you used. So that's what this inverse function does, is it tells you how many gigabytes you used based on how expensive your bill was. So if our bill was, say, $100, we could put that into this function. 100 minus 40 over 3 would be 60 over 3 equals 20. So if our bill was $100, we could use this function to easily conclude that we used 20